Hello friends, welcome to Cal Days. Hope you guys have an amazing day. So today we are going to deal with all those CSAT 2020 questions. So I think you all know the solutions based on the 2020 CSAT questions, but we are going to discuss all those all those steps, okay, or how to solve all those questions, okay, CSAT questions, all those arithmetic as well as logical questions. Okay, so let's start with our first question. So here, check the first question. How many zeros are there at the end of the following product? 1 into 5 into 10 into 15 into 20 into 25 into 30 into 35 into 40 into 45 into 50 into 55 into 60. So you can, a series of numbers is given and they are asked to find the product, and not they didn't ask to find the product, but we need to count how many zeros are there at the how many zeros are there in the final product that you are getting when you multiply all these numbers, right? So here it is a tedious task if you are multiplying all these numbers, right? So you are actually wasting a whole lot of time there, but there is a simple method in order to solve this. Okay, so listen here. Now when your first step is to factorize each and every number here. Okay, so you need to factorize each and every number, and your next step is to count the pair of 2 and 5s. Okay, make pair of 2 and 5s. So your first step is to factorize it, then make the pair of 2 and 5s, then finally count the total number of 2 and 5s. Then that number will be equal to total number of zeros, because 2 into 5 means what? 10. So you will be getting 1 0. Similarly, you need to find how many 2 and 5s are there. 2 into 5 pairs are there in the factorized, okay, in the factorized in the factorized equation. So count those pairs of 2 and 5, and that 2 and 5 is equal to 1 0, right? That means 2 into 5 into 20, so that will be equal to 1 0. So the total number of 2 and 5s will give you the total number of zeros. So total number of pairs 2 and 5s. Okay, now let's factorize each and every number here. So look here, 1 into 5 into 10, how you can write? 2 into 5, right? 15, how you can write? 5 into 3, right? Similarly, factorize every numbers. Okay, 20 you can, so 20, 2 into 5 into 2, 25, it is 5 into 5. So factorize like that till 60. Okay, now we factorized each and every number starting from 1 to 60, right? So I wrote in 2 steps. So here, now our next aim is to count the total pairs of 2 and 5. Okay, so look here. First of all, count the nearby pairs. 2 and 5, first pair. Now look here, 2 and 5, second, 2 and 5, third pair, 2 and 5, fourth, okay, 2 and 5, fifth, 2 and 5, sixth, 2 and 5, seventh, right? So you got 7 pairs which are nearby, right? Now find the 8th pair. So here you got a 5 and here you got a 2, right? So that 2 gives the 8th pair. Here you got a 2, here you got a 5. So that will gives you the 9th pair. And so what are the remaining pairs here? Here you got a 2 and here you got a 5, right? So that give you another pair. So there is no remaining pair. So there are 10 pairs of 2 and 5. Okay, 10 pairs of 2 and 5. So we can say that there will be 10 zeros. Okay, in the product you can say that there are 10 zeros. Okay, finally there will be 10 zeros in that product. Okay, so I think you all got the concept regarding the question. So if you get a question in future like this, just factorize it, okay, and arrange and just change, okay, substitute each numbers into its prime factors, okay, and just group the 2 and 5s together, then count the total number of 2 and 5s. That will give you the total number of zeros. Okay, total number of zeros, and okay, that will give you the total number of zeros. That pairs the total number of 2 and 5s in this final equation will give you the total number of zeros. So guys, now let's move on to our next question. Let x, y, z be a three-digit number where x plus y plus z is not a multiple of 3. Then x, y, z plus y, z x plus z xy is not divisible by Four options are given, and of course they are told that the answer is B. And now let's check how to solve this question. Okay, so here x, y, z be a three-digit number. Okay, so x, y, z is a three-digit number, right? Similarly, y, z, x also another three-digit number. Y is and zxy also another three-digit number. So any three-digit number can be expressed in the place in their number places, right? For example, look here, xyz. Xyz can be represented like this: 100x plus 10y plus z, right? Look here, for example, 236. 236 is nothing but 200 plus 30 plus 6, right? In the similar fashion, we can express x, y, z also, right? So, similarly, express y, z, x and z, x, y also. So, first of all, represent x, y, z. So, it will be 100x plus 10y plus z, right? Now, second term is y, z, x, right? So, it will be 100y plus 10z plus x, right? Now consider the final term: 100z plus 10x plus y. Okay, so we got it, right? Now our next aim is to add all those equal pairs. Add xyz plus yzx plus zxy. Okay, just add it. Just add these values. Okay, so 100x plus 10x, 100x plus x plus 10x. So we can write it as 100. I'll be writing all those values, right? So 100x plus, in second terms there is an x, right? X plus 10x, right? Plus 100y plus 10y plus y plus 100z plus 10z plus z, right? So it will be like 111x plus 111y plus 111z. Now take the 111 outside, so you'll be getting 111 into x plus y plus z. I think till this step you all got the concept, right? I will be explaining once again. Okay, I'll be explaining once again till this step. So your first aim is to split the numbers according to their numerical places. That is nothing but x, y, z can be splitted like this: x 100x plus 10y plus z. Similarly, split y, z, x and also zxy. Okay, and just add. Okay, that so we need to add the value, right? As the question saying, we need to add xyz plus yzx plus zxy is equal to, you will be getting, on adding you will be getting 111 x plus 111 y plus 111 z, and taking the 111 outside, so 111 into x plus y plus z. So you got the final equation. Now our aim, so from the question, so from the answer itself we can neglect x plus y plus z because the given number is divisible. 11 into 111 into x plus y plus z is divisible by x plus y plus z, because one of the factor is what of the final value is x plus y plus z. So from the final answer we got that. Now our next step, so we can eliminate the option D. Now check the three options. So now let's check this 111 is divisible by 3. If 111 is divisible by 3, then we can eliminate. If it is not divisible by 3, of course A will be the answer. Now let's check 111 is divisible by 3. So 111 divided by 3. 3 3s are 9, right? 3 7s are 21. Okay, yes, 111 is divisible by 3. So it is nothing but 3 into 37 into x plus y plus z. 3 into 37 into x plus y plus z. So you got the final answer as 3 into 37 into x plus y plus z. That means the final value so the factor of the final answer is 3, 37 and x plus y plus z, or the final answer can be is divisible by 3, 37 and x plus y plus z. So we can easily eliminate option A as well as option C, because option A is 3 and option C is 37. So the remaining option is 9. So our answer will be what? 9. Got it? Say easy question. So I'll be explaining once again. First of all, you need to split the uh, x plus y plus z according to their numerical places, then add x y z plus y z x plus z x y. So you'll be getting 111 into x plus y plus z. So from this we can easily neglect option D, because this answer, the final answer, this step, this is actually divisible by x plus y plus z. And now when you factorize this 111, you will be getting it like 3 into 37, right? So in the options you can say you can see option A as well as option C is 3 and 37. That means when you that means the final answer is easily divisible by 3 as well as 37. So you can eliminate option A and C, and your answer will be what? 9. So option B will be your answer. Okay. Okay guys, now let's solve the next question. Let P, Q, R and S be the natural numbers such that P minus 2016 is equal to Q plus 2017 is equal to R minus 2018 is equal to S plus 2019. One of the following is the largest number. Which one of the following is the largest number? So P, Q, R, S. Okay, there are four variables are given, and we need to find which is actually the largest number, largest variable. Okay. Now here it is said that the answer is C, that is R is greater. So let's check how we got R as the greater value. Now look here, P, Q, R and S. So there is a relation given, right? Look here, P minus 2016 is equal to what? Is equal to Q plus 2017 is equal to R minus 2018 is equal to S plus 2019. Okay, so this is actually the given relation, right? So we can say that P minus 2006. First of all, from these two relation, we can find that which is greater, P or Q. Okay, first of all, we can find whether P or Q is greater. So P minus 2016 is equal to what? Q plus 2017, right? That means P is equal to what? P is equal to Q plus 2017, right? So that is P is equal to Q plus 2017. That means P is greater than Q. Okay, so from equation 1 we can say that P is greater than Q. Okay, got it. Now consider, so we got that P is greater than Q. Now find the relationship between P and R. Okay, find the relationship between P and R. So you find the relation in such a way that the greater number with the remaining variables. Okay, so from the first step we got that P is greater than Q. Now the next step is to find the greater variable, the relationship between the greater variable and the remaining any one of the variable, right? So here the greater variable is P, so I am going to find the relationship between P and R. Okay, now look here, P minus 2016 is equal to R minus 2018. Okay, so from this we can say that P minus 2016, okay, plus 2018 is equal to R. P minus 2016 is equal to R minus 2018. So this 2018 coming to LHS, it will be turned to positive. That is P minus 2016 plus 2018 will give you R. So P plus 2 is equal to R. P plus 2 is equal to R. So you mean here P plus 2 is equal to R. That means R is greater than P, right? R is P plus 2 is equal to R. That means R value is greater than P. So we got that R is greater than what? P. Okay. Now here R is greater, right? So find the relationship between R and S. Okay. So look here, R minus. So let it be equation 2. Now consider equation 3. R and S. Okay. So R minus 2018. R minus 2018 is equal to S plus 2019. Okay, R minus 2018 is equal to S plus 2019. That means R is equal to what? S plus 2019 plus 2018. That means R is greater than S. Okay, R is greater than S. So we got the relationship between all these values, right? So either I think from this itself we can say that R is a greater value, right? Looking here itself, we can say R is a greater value. So you actually don't want to find the relationship between P and S or Q and S. Okay, from this we can say that R is actually the greatest value. Okay, so our answer is C, R. Okay, now let's solve this question. how many 5-digit prime numbers can be obtained by using all the digits 1, 2, 3, 4 and 5 without repetition of any digits. Okay, so here this question is very simple. So here you can apply a property. Okay, so the numbers are what? 1, 2, 3, 4, 5. Okay, so 5 numbers are given. How many 5-digit prime numbers can be obtained by using digits 1, 2, 3, 4 and 5 without repetition, right? That means there is no number is repeating. Okay, so the numbers can be 1, 2, 3, 4, 5. That is 12,345, or it will be 13,245, like that. Likewise any numbers. Okay, that means the number is actually not repeating. Okay, each number is not repeating. Okay, so in order to solve this, first of all add these numbers. Okay, 1 plus 2 plus 3 plus 4 plus 5. Okay, so 4 plus 5 9, 9, 10, 11, 12, 13, 14, 15. So you got 15. Okay, so when you add these numbers, okay, when you add these individual numbers, it's actually a property, right? When you add these individual numbers and you got a composite number. Okay, it's actually not a prime number. So that means when you add these 5 numbers, you got a number 15 which is divisible by 3. So if any number formed by these 5 numbers, it will be actually divisible by 3. You can check it. Okay, that means if you are forming any number of numbers, okay, without repetition, using these 5 numbers, then that number will be divisible by 3. Okay, so that means when you add all these numbers, you got 15, that is actually divisible by 3. So this is actually a property. So keep this concept in your mind. So here our answer is 0. That means you can't make any numbers. Okay, you can't make any prime numbers with these 5 numbers. As the sum of these all 5 numbers, you will be getting 15, and that 15 is actually divisible by 3. Okay, so the number you are making with 1, 2, 3, 4, 5 will be any numbers you are making with these 5 numbers will be divisible by 3. So here our answer is 0. Okay guys, now let's solve this question. So here there is a relationship given and we need to find the missing symbol. Okay, so let's solve this. First of all, let's copy the relationship. So here asterisk plus 1 asterisk plus 5 into 5 asterisk plus asterisk asterisk plus asterisk 1 is equal to 1 asterisk asterisk. So certain numbers in certain places is missing. That means all these asterisk numbers are equal and all those missing values are equal, right? So we need to find which value is missing, or we need to substitute a proper value for this missing. Okay, or these asterisk values right here. Okay, instead of this asterisk symbol, we need to substitute a proper value, and we need to satisfy this condition given here. Okay, for that the only method to solve this type of question is just by trial and error method. That is substituting the optional values and whether you are getting the correct answer or not. Now let's solve this here. Now here, first of all, now check the ones places. So these are the ones places, right? Ones places. Now and here. Okay. Now I am going to substitute the value 2. Okay. I am going to substitute value 2 in all these ones places. That means if you are substituting the value 2 for the asterisk, here also you need to get the value 2. Okay. Now let's substitute the values of value 2 at the ones places. So here I am going to substitute value 2. That is 2 plus 2, 2, 2, and here you need to get the value 2, right? So 2 plus 2, 4, 4 plus 2, 8, 8 plus 2, 10, 10 plus here 1 only, right? In one's place, the 1 value. So 10 plus 1, 11. So here the asterisk value is here in the answer side, the ones place you are getting the answer as 1, right? That means when you substitute the asterisk value 2 in the left hand side, in the RHS side, you are getting the asterisk value as 1. That means 2 is not the correct substitute for the asterisk. Now instead of 2, I am substituting the value 3. Okay, I am substituting the value 3 on the asterisk symbols. So when you substitute the value 3 on the ones place, okay, for the asterisk, you need to get the value 3 in the answer section ones place also, right? So I think you all know the concept of ones, tens, hundreds. We already had done a question just a moment before, right? So look here. So substitute the values 3 on the ones place asterisk. So 3 plus 3, 6, 6 plus 3, 9, 9 plus 3, 12, 12 plus 1, 13. So here asterisk value you will be getting 3. Okay, 13, 3 and 1 will be gone as a reminder. So when you substitute the asterisk value 3 in the LHS side, you in the RHS, in the answer side also you got the ones place. In the ones place the asterisk value you got it as 3. That means this condition is actually satisfying for the value 3. Okay, when you put the value 3 on this, look here, 3 plus 13 plus 53 plus 33 plus 31 is equal to 133. Okay, so you will be, that is when you put the value 3, this condition is actually satisfying. So we actually don't want to substitute all the values 3's, okay, onto the asterisk symbol. Just first of all substitute for the ones place, okay, and when the LHS becomes, that means the LHS asterisk symbols value is equal to the RHS ones place asterisk value, then you got the correct answer. Okay, so here the answer is 3. When you substitute the value 3, you got the correct answer. Okay, 3 is the correct substitution and our answer is B. Okay, 3.